Morning folks, it's me again. Hope you're all keeping well and safe. Here's your work for today. We're going to be looking at something slightly different actually. Fractions 2. So the first thing we're going to look at is this concept of what is a reciprocal. And you may or may not have heard of this word before, but reciprocal is a pretty important part in fractions and also gets used in other parts of maths, including algebra. So what I'm going to do is going to talk you through what it is. So a reciprocal, to define it, it is what you get if you divide 1 by a number. So it is the number obtained when you divide 1 by that number. Okay. Now, the characteristics, well, quite important, all right, what you get in terms of any reciprocal and the original number will always multiply together to make 1. So, a number and its reciprocal always multiply together to make 1. Okay, and that's really important. The other thing that we know about a reciprocal as well is, in order to obtain it, yes, you can divide 1 by that number, but what you can also do, if you have a fraction, you can just flip it upside down. And so I'll write that in this box as well. The reciprocal of a fraction is found by flipping the fraction upside down. Okay, I'll scan all this for you in a bit. So, examples. Well, if we have a number, so for example, you can pick any number, it doesn't really make a difference. So if we have 14, for example, the reciprocal of 14 is just 1 divided by that number. So this is 1 divided by 14. I would always advise you leave it in terms of a fraction. It's really important when you're doing. I mean, that's why we call it fractions 2 here. So don't worry about decimals or anything like that. It doesn't matter what that number is. So if you had 73, that would basically be 1 over 73. Notice I'm not with equals and putting an arrow because it's not the same number, not the same value. If you have a fraction, for example, 3 over 8, the reciprocal of that would be 8 over 3. Okay, all you would do is just flip it upside down, turn it upside down, and so on. Okay, it doesn't matter what that fraction is. Okay. Just do a couple more down here for you. Again, if you had a fraction, perhaps if you had something like 1 over 12, if you flipped it upside down, because it is a fraction, you'd get 12 over 1. Would you leave your answer like that? Well, 12 over 1, 12 divided by 1 is just 12. And so in terms of that one there, we could just say 12. And what you'll notice is the reciprocal of a 12th is 12. The reciprocal of 12 is a 12th, and it basically bounces back to and from, to and from, to and from. Okay, and so that's really important. The last one I'll just say, I was going to do an example. If you ever did get a decimal, for example, so if you had 0.4 and you had to do it, I would not dream of writing 1 divided by 0.4. It's just not what you do, mixing fractions and decimals. So what I would say to do is, in this case, with your decimal that you've got here, turn it into a fraction. So 0.4, what is that? Okay, we need to think about that as a fraction. So it's 4 over 10. 4 over 10. Can we simplify it? Yes, we can. So that is 2 over 5. And now we've got 2 over 5. What does 2 over 5 go to? We just flip it upside down. 5 over 2. So if you ever did get a decimal, basically change it into a fraction. I'll just write back up here as well. The button on the calculator, if you do have your calculators at home, you may well see this button It's x, oh no, algebra, with a little -1. That is the button you'll find on your calculator or do reciprocals. So non-examples really, what are not different ones? Well, I'll show you here is, and I'll explain about this multiply together to make 1, because that's the idea. So if you said, for example, excuse me, 2/7 and 9/2, they're not reciprocals. How do I know? Because 2/7 times 9/2, if we do it, 2 times 9 is 18, 7 times 2 is 14, that is not equal to 1. And that's the way we'll know that they are not reciprocals. Okay, and that's really important as well. Okay, so remember, reciprocals will times together to make 1. They have to. Okay, absolutely have to. Okay, we're going to just do some examples here, a bit of maths. We'll see whether they are or are not reciprocals. So in this case here then, times into fractions together. You'll know from this before, you've done this before, times across the top, times across the bottom. So 2 times 5 is 10. 3 times 8 is 24. Okay, are they reciprocals? No, they're not, because we've ended up with an answer of 10/24. If you want to simplify it, you get 5 over 12. There you go, half asleep. But no, they're not reciprocals in that case. This one here, 5/6 times 3/2. Again, we'll just write it out. 5 times 3 on the top, 6 times 10 on the bottom. What does that give us? 15/60. All right, there you go. We can simplify that one, just divide by 15 top and bottom, so that's 1/4. Okay, again, we've got 2 values here, but they weren't reciprocals because they didn't give us 1 when we times them together. Next one, 3/4 times 4/3. Let's do this. 3 times 4 on the top, 4 times 3 on the bottom. So 3 times 4 is 12. 4 times 3 is 12. Oh, hold on. 12/12. 12 divided by 12 is 1. And so this one here, they are reciprocals, okay? And so what we could say is 3/4 and 4/3 are reciprocals. Okay, this one here, 5 times 3/4. We've said before, if you ever have a number, just times a fraction, best to make them both into fractions. So 5/1 has the same value as 5. If we times it by 3/4, we'll get 5 times 3 on the top and 1 times 4 on the bottom. Gives me 15/4. I'm going to leave it like that. There's no point worrying about doing anything with it. It's an improper fraction, but that's cool. Okay, but they're not reciprocals because they don't give us 1. And we're now going to move on to this because, oh no, algebra again. But the big thing about algebra is it works exactly the same way. So in this case, 2c on the top is going to get times by 3. 5 is going to get times by 9c on the bottom. So if we do this, 2c times 3, we've done this before, that's 6c. 5 times 9c on the bottom is 45, is 5, 9, so 45c. You go, get a fraction. Let's not worry about it. In this case, we'll simplify it. Well, let's just have a look what's common on top and bottom. C and C, well, they'll cancel, won't they? Because, you know, you can divide top and bottom both by C. 6 and 45 are both in the 3 times table as well. So we'll simplify by, you know, divide by 3C top and bottom. That would leave you with 2/15. It's okay, there's your answer. Are they reciprocals of each other? No, because we didn't end up with 1. And that's the key thing. We'll have a look at this one now. 2ab times 3a in this case here. So again, just the same top and bottom. So 2ab times 3a and 5 times 10b on the bottom. What does that give us? Well, 2 times 3 is 6. A times a is a squared, and you've got the b, so a squared b. And then here on the bottom, 5 times 10 is 50, and so 50b on the bottom. Want to simplify it? Yeah, I'm just pretty used to simplifying it like that. So 6 and 50, they're both even, so we'll halve them both, all right, to get 3/25. A squared on the top, there's no a's on the bottom. There is a b on top and bottom, so we can cancel the b as well. So b will disappear, and as I said, 6 and 50 will just divide by 2. So we'll go with 3a squared, left over, and on the bottom we'll end up with 25. So there's your simplified version of that. Are they reciprocals? No. Why not? Because we don't have 1 as our answer. Okay, I'm going to give you a few questions to do in your turns to have a go at these. Not too difficult, actually. I hope you'll get on all right. So take care of yourselves. See you soon. Bye-bye.